The directions here are to evaluate this, and this meaning find the second derivative of this function with respect to x. Well, to find this, we have to first find the first derivative. So d over dx of this hot mess, this is a quotient. We're going to have to use the quotient rule, which says we take the derivative of the numerator, multiply that by the denominator, subtract from that the derivative of the denominator, and multiply that by the numerator, all over the denominator squared. The derivative of x squared plus 1 is 2x. We bring down the x cubed minus 1. Bring down the minus, and we have the derivative of x cubed minus 1, which is 3x squared. And we bring down x squared plus 1. Our denominator, we're just going to leave it. There's no point in squaring it. Simplifying, if we distribute the 2x times each of these terms and distribute the minus 3x squared times each of these terms, we're going to get 2x to the fourth minus 2x minus 3x to the fourth minus 3x squared, all over a denominator of x cubed minus 1 quantity squared. Like terms, 2x to the fourth minus 3x to the fourth. It's going to give us a negative x to the fourth. Bring down the minus 3x squared, the minus 2x, and our denominator, x cubed minus 1 quantity squared. This is the first derivative of this function. Now we have to repeat the same process to find the second derivative of this function. To find the second derivative of this original function, we have to first find the first derivative, which we just did. So once we found that first derivative, which was this, we take the derivative of that. In other words, the derivative of the first derivative is going to give us the second derivative of the original function. There's a problem we have right now, and that's this bottom. This bottom is a function raised to a power. We don't know how to find that derivative. So before we try to find the second derivative, this part right here, we need to figure out what this bottom here simplifies to. It's going to simplify to x to the sixth minus 2x cubed plus 1. That needs to be done before we can actually find this derivative, because we can't have a function raised to a power. We don't know how to do that yet. We will learn that in time, young one. Be patient. So what we have to do now is we have to find the derivative of this which is the second derivative of this original function up here. So to do this, we take the derivative of the numerator times the denominator minus the derivative of the denominator. I am running out of space. Times the numerator all over the denominator squared. That's going to give us a negative 4x cubed minus 6x minus 2 times x to the sixth minus 2x cubed plus 1 minus 6x to the fifth minus 5x times negative x to the fourth minus 3x squared minus 2x all over the denominator squared x to the sixth minus 2x cubed plus 1 quantity squared. So this is the second derivative. Everything you see here, we're not going to simplify it. We're not going to multiply this trinomial times this trinomial and this binomial times this trinomial. Too much work. We know how to do it. There's no point in doing it because it's just a waste of our time. So this is the second derivative.